So today we're going to be continuing that. I want to make sure we have plenty of time to establish this really solidly. So let's do a quick 1 to 3 scale. Presumably you all are familiar with how I do those by now. So a quick 1 to 3 in Slack. I want to get a sense of where people are at with control flow. How are you feeling about control flow? And for this, I do expect everybody to post in, please. Or I request that everybody post in. Okay, we got some 2s, got some 3s. Okay. I'm seeing like 2s, high 2s, 3s. Seems good. All right, if you're not quite at a 3 yet, that's okay. We'll be kind of fleshing that out as we go. So this is basically what I was hoping for. Seems fairly more or less even between 2s and 3s. Okay, thanks. Let's see. Let's do the same thing. I should mark these ahead of time. Control flow up there and functions below. So 1 to 3, how are you feeling about functions? Okay, thank you. 2.125. It's some pretty precise floats here. That's fine. So this seems about the same, maybe a little more 2s on this one. That's okay. That's great. That's actually really great. Thank you for that. So I'm going to do the overview. I'm not going to make you do it this time, but I do want to just reinforce it. We'll go real quick. Overview. So you've got your data types. I'll come to that. Abstractions. Control flow. Iteration. Data types we've talked about are int, float, bool, string, none. Pretty soon we're going to talk about lists. Abstractions, variables. Nice and simple. You know, just being able to give a name to some data. Functions, kind of like being able to give a name to some process and being able to give inputs to that process and expect and define an output for that process. It's a little more complicated than variables, but you know, simple idea at the end of the day with not too many moving parts. Control flow, we've got if, elif, else. Allows us to write dynamic code, and Seems like people are doing all right with the last two concepts that we covered, so I want to do kind of a quick recap, and then maybe we'll get into iteration today. That'd be kind of cool. So iteration. Iteration allows us to repeat processes. We'll call this iteration slash repetition. We have two primary tools for that. We have for loops and while loops. And as you'll see, we'll get into more of the nitty gritty of this. While loops are more powerful than for loops in that while loops, you can solve any problem that you can solve with a for loop, you can also solve with a while loop, maybe in a slightly different way, but the reverse is not true. The reason we have for loops, and in general you want to write for loops, the reason that they're preferable is that they are easier to manage and they are not prone to infinite loops. It's very easy to accidentally write a while loop that gets into an infinite loop, which is not a great, it's not generally what you want to do. There are times when you apply infinite loops to various problems, but in general you don't want to just write a loop that just goes forever without anything stopping it. So for loops, I think I've seen in what, 2.5 years of doing this job, I think I've seen somebody accidentally write an infinite for loop 2, maybe 3 times. So maybe not even 3. So it's pretty hard to accidentally write an infinite for loop. It can be done, but so for loops for the problems that they can solve, and there's quite a lot of problems that they can solve, are just nicer to deal with. They're easier to maintain, they're easier to manage, they make your code a little more elegant and succinct. So that's why they exist. Give you a little window into that. Okay, so I'm gonna open up, if you have any questions, hold on. We'll kind of, I'm gonna go through some functions examples and kind of try to reinforce what we did last time. If anybody has questions regarding functions, sort of primarily and secondarily control flow, feel free to put them in there if there's just something that you want some clarity on. I might cover it, and we will go from there. What happens when there's an infinite loop? That's a good question that will pertain to when we get into loops. Sorry, I kind of dangled that in front of you, and now we're moving on. Yeah, so if you get it into an infinite loop, basically it's just your program doesn't stop. It doesn't have a way of stopping, so it runs forever. You can force it to stop. But it doesn't have a way to stop itself, so that can cause various problems. It'll heat up your CPU. It won't like light your computer on fire, I don't think, but like if you let it run long enough, you've put your hand over wherever your CPU is, you will feel it heat up pretty quickly, so not a great thing to do generally. Like I said, there are some problems where you're effectively running an infinite loop, but that's not a common thing. I've never needed to do that. I could foresee it as a potential thing that you could do, but it's generally a problem, not something that you want to do. So anyways, we will dive more into that once we get into for loops and while loops, which looks like we're probably going to have time to do today. So I want to cover this. I know we talked about it before. Quick note on Slack etiquette. Everybody see if you can paste in something like like this. So I just pasted in a formatted code cell with 2 lines of code. I don't really care what your lines of code are. I don't even care if they are lines of code. The goal of this is to just try to paste in a correctly formatted code cell. In order to do that, in the Slack window where you type your message, you hit the backtick key 3 times. And to be clear about this, the backtick key is not the single tick quote key. But the backtick character looks a lot like a single tick quote, but it's not. Or I'll show you. Backtick, single tick quote. See if I can screenshot that real quick. So the one on top is the backticks. And when you hit the backtick key 3 times, it should just make a box. Like a box just spontaneously appears for you to type in. It's a box within the input box. Cool. I think I see most people have this. Thank you for doing this. If you're still struggling with this, let's sync up after class and I will present my screen, which I can't do right now, obviously, because people's names are in there. And this is going to be a publicly posted video, so great. If you haven't gotten an answer in, please do so. And if, yeah, like I said, if not, then please stay after class and we will go over this again. The reason I want to emphasize this is when you all paste in code, if you don't format it and I copy paste it in, a lot of people's errors have to do with indentation, and there's no guarantee if you paste in unformatted code, it's probably not going to retain indentation in the way that you intended it. So I'm going to be left to like infer what that indentation would be. So it can, since indentation is so important in Python, it can change the way a program runs. So when you paste in formatted code, it will retain that indentation. So it makes, when you ask for help in Slack, it makes it much, much easier to see what your code is doing and for me to copy paste it and go from there. This is a quick breakout. We've done this one a while ago. I'm just going to go over the solution to this really quick. The 4 scalar types we've discussed there. That's actually 5. Excuse me. And float, bool, string, and none. 1 over 100 to the power of 100,000 gives us 0 because the value is too small to represent with a float. So the value is so precise that it can't be represented by your machine is physically incapable of producing a number that is that small. So computers are what's called finite precision machines, and that's why, because the amount of precision that can be expressed and calculated is limited. Okay. 3 double equals 3. We have the equality operator. The equality operator is 2 equal signs next to each other, and what it is it's a check for equality. It checks if the thing on the left and the thing on the right are equal in value, not necessarily in type, but in value. So 3 double equals 3 is true. This expression gives back the value true. Bang equals or exclamation point equals, we'll usually just call that bang equals, or not equals. This is often read as, or usually read as not equals actually. 2 not equals 2 is false because 2 is equal to 2. It's just the opposite of equality there. I'm going to give you this breakout. I'm going to pop 3 minutes on the clock. Here we go. Okay, and I see some people running this with or just giving one answer back at a time. We want to try this code with all four of these. All four of these. Oops. Freaking missed one. Okay. So I'm just going to give this a run. And we want to test it with these four, so I'm going to cheat because why not? I'm going to wrap this into a function. We're going to say def some function. We'll take in, I'm going to call it x. And then we're going to some function we'll take in x, and we're good to go. Oops. So, the cool thing about this is if I write this as a function, I can test this with different values for x here. Okay. Hoping everybody's good on questions. If you assign a number to a variable and then assign a new number to the same variable, doesn't that get written over by the new assignment? Yeah, okay, yep. Yeah, so this, in this case, it does. If you wanted to keep this outside of a function, if you wanted to do this outside of a function, I mean, you could write the code 4 times or whatever, or you could just have like the variables and then try one out at a time. So you could try 9, and then you could comment that out, try 80, and then 25, and then 66. But the nice thing about, obviously, the nice thing about having it inside of a function is I can just do those all at once. And the whole process is automated. I just run it once and it does whatever I need it to do. elif is meant to replace if when using multiple conditions, right? Depends on what you're trying to accomplish. If you have let's say multiple things that could be valid consequence or conclusions, if you have multiple valid conclusions, but only one can be valid at a time, you need to chain them together with ifs, elifs, and maybe an else, or maybe an if and an else. If you have a scenario where multiple conclusions can be valid simultaneously, then elif must not replace if, and then you have consecutive ifs. So it's not as much meant to replace if as it is to, it allows for a different logical structure. It depends on what your goal is and what the scenario demands. Hopefully that makes sense. Shouldn't 80 print give me 10? Okay, let's look at 80. Yeah. So 80 gives high 5. This is interesting, right? So this code is silly. There's something silly about it. I didn't write this challenge, by the way, just full disclosure. I inherited this challenge, and I've kind of kept it around because the quirkiness of it is interesting, and somebody points this out usually, and if not, I'll point it out. Or I'll try to remember to point it out with this problem. So there is something legitimately wrong with this. I mean, I think you could argue that, but we have some dead code. I think it's probably obvious from the question, shouldn't 80 print give me 10? And me saying we have some dead code, probably obvious what the dead code is. I'll give a little snapshot of this though. And we'll reference things by line number here. So which line, or I guess you could say lines, are dead code? And why? Go ahead and put it in Slack. We'll treat this like a little breakout. Another way of asking this, you could answer the question, why doesn't 80 print this? If it meets the first condition. Line 26 is true, so other conditions are not addressed. Assessed, yes. Yeah. Yeah. So if we look at this, line 28 will never be true. I mean, even if both of these things are true about x, we check line 26 first. So since line 26 checks if x is divisible by 5, and line 28 checks if x is divisible by 5 and by 2, we already, if x is divisible by 5, it already executed one of the conclusions. So it never bothers to check this. So if line 28 is true, then it can't be checked. It's weird. It will be checked if it can't be true. So if x is not divisible by 5, line 28 will be checked, but it will be false. So it's a weird paradox, right? Sometimes this will be checked. All the times that it will be checked, it will be false. Sometimes it won't be checked. All the times it won't be checked, it might be true. So how could we fix this code so that we could rectify this so that we get 80 printing out with the correct value? And I'll paste that in. You can copy paste or do whatever you want with it. Show me the solution. Nicely done. Some people are suggesting an if instead of an elif. We could try that. That's not necessarily wrong according to the way I asked the question. So I'll let that slide because I wasn't necessarily specific enough. This would make this run, but what we actually want here is an exclusive. We want only, when both of these are true, we want only this to run. And when only this is true, we want only this to run. So we do want things to be exclusive. If I change this to an if, it'll run it, but you can see we get extra lines. We get extra lines of code there. So okay. So the solution that I would do for this, and so what I think I saw most of you do, we'll do an elif there and an if here. So I just changed the order. This is the second condition and conclusion. This is the first condition and conclusion. I just swapped their order. So if I do that, and these are still chained together with elifs, then I'm going to get that. Cool. So this is an interesting one. You have to watch out for that kind of thing. The order that you check conditions often matters quite a lot. Okay. This is a little section on printing to the console. I'm going to guess that everybody understands what print is. There is something important here, and I'm kind of violating this rule in this particular case because I just copied this code, and this code had print in it, and my decision was to put it in a function. In general, with a function, I would want to return from it. And then if I run this, nothing's going to happen because the function now has values. And we can print that value because we're returning it, right? So in general, this is preferable. You want your functions to return values. When I say generally you want your functions to return values, what I mean is like almost all the time, like 99.99% of the time. It's pretty uncommon that you're, I'm not going to say you're never going to do it, but it's pretty uncommon that you write a function with that doesn't have a return. It is something that you could do, but like I said, it's not common at all. So vast majority of functions are going to have at least one input and return something as well. So you want to think about your functions returning something. And then you can print off the call, the invocation of the function, wherever you call the function. You can print off that invocation, and you'll see from the print what it returns, right? And this is different than printing here. That's a distinct thing from printing inside the function. I will use prints inside my functions to debug things, and then after I'm done, I'll delete them, or I'll comment them out. There's some cases where, like, if I'm doing something in a weird way, I might put in a print maybe that helped me solve a problem or that shows me something about it, and leave it in a comment and keep that comment permanently just to say, like, you know, hey, if you're trying to understand this, uncomment this print and it'll kind of show you what's going on. There's times when I've done that, but generally the times I'm using print inside my function is for debugging, for problem solving, as I'm working through writing the code. And then once I've finished, usually I just delete the prints. Okay, cool. So the takeaway from that is print and return are not the same thing. This is a mistake that a lot of you are still likely to make. That's okay. I needed to make it. I needed to learn that one the hard way. When I was learning, I made that one a lot. It can cause a lot of weird issues. I kind of want to explore that a little bit. Let's do an add nums function. Def add nums. We'll take in A and B, and it'll print 3 plus 8. Okay. So if I say add nums, what am I doing? It'll print A plus B. Sorry. and then we'll do 3 plus 8. Okay, so 3 plus 8, it's going to be 11, right? So this looks fine, right? All this does is print the result of these numbers. It doesn't actually, this function does not evaluate to whatever the sum of its inputs are. It just makes them visible on the console. So this is a problem. Say, if I wanted to say 11 equals 3 plus 8, and then print 11 plus, right, 11, it should be a number. 11 plus 9. This is going to be an error, right? There's 11 because we printed it there. We scroll down, we get a type error. Unsupported operand types for plus between none and int. Anybody know what's going on here? Anybody know or have a speculation? Speculation's welcome. Yeah. Nope. That's an acceptable answer. Nope is an acceptable answer. What's the value? Here's another way of asking this. What's the value of 11? Which I can find out by printing 11. Do you have some JavaScript programmers? When you're saying undefined, do you mean like undefined is in the JavaScript value? Or like it hasn't, because when Python says something is not defined, it's different than quote unquote undefined in JavaScript. It just means that you're trying to use something that just does not exist at all. So anyways, is not defined. Okay, yeah. Saw a few people say undefined in there. Okay. Yeah. So 11 is none right now. So 11 is defined. Yeah, I mean, it's fair to think that it's not. I mean, this is a little bit weird, right? But if we print this off right now, the value of the variable 11 is none. You see? So that's because I didn't specify a return here. I know this is obvious, this is a mystery we already knew the solution to because of the way I framed this, right? But this is why it's more desirable to return from your functions, and then you can do whatever you want with the function. You can print, if you want to print it off, you can do that, or since you're giving a value back, you can use it as the value that it returns without printing it off. And if you want to print it off, you can still print it off. You just print it off in the invocation rather than inside the function. You print it off in the invocation rather than the definition. So that is something to watch out for. Okay. So let's see here. we're doing pretty good on recapping stuff that we covered yesterday anyways, because I wanted to do a function with multiple inputs here. I think we should move on to lists and loops. I think we should just do it. Yeah, let's pivot a little bit. Maybe I'll keep some of this stuff for review for later. I want to just kind of search through here real quick, make sure there's nothing worth mentioning. I mean, there's a lot of good stuff in here, but we covered most of it. What I wanted to cover at least. Okay. There is one thing actually that I want to cover. Let's cover default arguments and then we'll move on to lists. I don't want to bore you all with too much review, but these are, this is an important concept, so it's worth establishing well. So let's do, we talked about parameters, arguments. Let's do a quick one. What's the difference in your own words? The difference between parameters and arguments. When do we call something a parameter? Yeah, that's actually a better way of asking it. When do we call something a parameter and when do we call something an argument? Parameters are defined in the function. Arguments are actual values passed in. Parameters convey values, i.e. arguments, to the function. You call it a parameter when creating the function, and you call it an argument when using the function. I like that. Parameters are defined in the function. I would say in the function definition, but I get what you're driving at. Arguments are passed to the function in the function call. Yep. Cool. I won't read through all of these, but yeah, I'm generally seeing the correct answers here. So parameters happen when the parameters are what we call the inputs to the function when we're defining it, and arguments are what we call the values, the specific values passed meaning given to, the specific values passed to the function when we invoke the function, when we call the function. So during definition, we define a function with parameters. We invoke the function with arguments. If you want one word to just say for both of them, just say arguments and you will be understood. It's technically a little bit of a misnomer, but it's something that is understood and accepted for the most part. So if you want to just call everything arguments, you can do that. Or if you want to use them interchangeably, you can do that too. But it's sort of more acceptable to say like you're defining a function with arguments than it is to say you're calling a function with parameters. So if you say it the wrong way, one of the ways, say arguments, or say inputs to the function. That's also a good way to do it. Okay. So let's look at Let's look at an example. I want to show something called default arguments. This is formally called default arguments, but it's something we do to the parameters, which is basically we're saying, hey, if I don't give an argument here, I want you to assume that I meant this argument. So it defaults to a certain argument. So let's say add nums, def add nums. We're going to take in A, and we'll take in B equal to 1. So notice I'm assigning a value here. Remember in the beginning I said you can't do this? You don't always want to do this. This is not something you always want to do. Definitely not, like in principle. But it's something that can be really useful. So we'll return A plus B. So now what this is going to allow me to do is I can use this function just as I had been using it before. If I wanted to add 3 and 7, I'll get 10. But let's say I just wanted to increment something. Let's say I have 15 and I want to just increment it to the next number. I mean, I could do that anyways pretty easily, but this will just increment it by 1. So this allows me, remember before when I tried to call, what was it, the subtract function? I forget exactly what function I was working on, but I gave some examples where I defined a function with 2 arguments and I tried to call it with less than 2 arguments and with more than 2 arguments, and it gave me an error in all cases except when I called it with exactly 2 arguments, right? So in this case, I define a function with 2 arguments, but I default one of them, and then I have one place where I can call it with 2 arguments, and another place where I can call it with only 1 argument because the second argument is defaulted. So what I'm telling Python is, with this second call, I'll just focus on this second call, pass the value 15 into the parameter A, and then since I didn't pass a value for B, just assume that I want B to be 1. So I can tell Python to make the assumption that I want it to be 1 there, and then return A plus B. This will return the sum of those, right? So A is 15, B is 1, 15 plus 1 is 16. I could default both of these if I wanted. Currently, just like, let's just be clear here. If I call this with nothing, it says it's missing 1. Remember before it said it was missing 2 required positional arguments. Now it says it's missing 1 required positional argument, A. Because B is no longer a positional argument, essentially. I can pass in a value positionally, but it's kind of a different argument now. So, or it's no longer required. That's what I meant to say. So there's a little bit, it's a little bit tricky when you're adding in defaults, and I wanted to wait to talk about this. I didn't want to talk about it yesterday. I wasn't sure I wanted to talk about it today, but I think y'all are ready. So when you're adding in defaults, the order, or how do I put this? Your default arguments have to come after your default. Let me try that again. Your parameters with default arguments have to come after your non-default parameters. If I do this the other way around, if you think about it, you'll see it. If I tried to do A equals 1 and B equals, or just, if B is not defaulted, right, and tried to do the same thing, you might think, oh, well, that's going to be the same as if B is equal to 1. If B is defaulted or A is defaulted, you might look at this and say, well, 6 1, half a dozen of the other, who cares, right? But if you think about it, you'll probably think, but wait, when I pass an argument, which one does it go to? Does it go to the one that has an assumption made about it? Or the one that doesn't? Well, it should go to the one that doesn't, but the one that doesn't is the second one, so I would have to pass a second argument, in which case having a defaulted value would be meaningless. So you get into this sort of recursive cycle where it's like, in order for this to make sense, you have to have two arguments. If you have two arguments, there's no purpose in having a defaulted value. So if you think about it, there are ways where you could make this work, right? Like it is possible that they could have said, well, since A is defaulted and we only have one argument, then we'll pass the argument to the parameter that doesn't have a value. But this is starting to get weird. This behavior is starting to get convoluted. And if that was the behavior, what the heck would you do with this? And you could probably think of a logical conclusion, at least one. That's one of the problems, is I think there's multiple kind of equally valid logical conclusions about what the behavior maybe should be for this, but your guess is as good as mine. So like being able to look at this and discern what argument should go where is complicated. And so Python just doesn't allow it. The only way you can do defaults is if all of your non-defaults are on the left and all of your default arguments are on the right. That's the only way to do it. So if I try to run this, it's not going to plug in 15 to A and then push 1 over to B, and it's not going to plug in 15 to B and assume that I wanted A to be 1. It's not going to do any of that. It's going to give me this specific error for this specific situation. So syntax error, non-default argument follows default argument. So this is an error that is handcrafted specifically for this exact scenario. So you always want to do your defaults on the right. If that's not totally clear why, you don't really need to it's not common that you need to do defaults. It is something that we'd want to see eventually, but it's not something that you really use all that often. Like most of the functions you write probably aren't going to have a default. It can be really useful for things like, let's say you have a function that covers a wide variety of use cases, and maybe because of that you're writing it in this really generic way where you could have like 6 or 7 inputs into the function, but you know that for like 95% of the cases where you're going to use that function, 5 of those are going to be the same. So really, most of the time, you're just going to need to pass in the first 2 values, and then you can just configure the others. You can default the others so that they're configured for you. So there's some kind of cool things you can do with that, but in general, at least for most of this class, just using regular non-defaulted arguments is fine. If you do want to use defaults and you don't necessarily remember why you can't do what, just remember defaults on the right, non-defaults on the left. Okay. I know that's a little bit weird, but Cool. All right, we're about halfway. Let's reconvene at, let's see, let's reconvene at 8 minutes after the hour, and we will start in on lists and loops. right. We're ready to reconvene. Go ahead and turn your cameras back on if you don't mind. Helps me get a sense of who's around and who's engaged. And well, not really who, not like I'm really keeping track of you. Just that people are engaged and are around. It does help me out. So go ahead and sit down, take a stretch. Let's get ready again. Oh, I'm gonna stretch too. Oh, this is nice. Okay. Here we go. Cool. So this next one's about lists. Not loops specifically, but I want to talk about loops in with this. So we'll kind of introduce lists and loops as concepts together. So let's talk about this in terms of the overview real quick. So I mentioned lists, and lists are a really important data type. They're our first mutable data type. So all the other types we've looked at so far hold a single value at once. They're immutable. They just are what they are. So if I make a string or a number, what you usually do is you save that maybe to a variable, whatever that string or that number is, and you can do transforms on that type. Like if I add to a number, if I add 6 to 7, I don't change the 6 or the 7. It just gives me 13, right? It just produces another number, which is 13. That 13 isn't a modification. It doesn't like go in and change the 7 to a 13 or the 6 to a 13. It just gives me 13, right? It'd be kind of weird if it changed one of those numbers. Same thing with a string. If I concatenate to a string, it gives me a different version of that string back, right? So if I have hello and I concatenate world to it, it doesn't change hello or world to hello world. It just gives me back another string, which is hello world, right? So lists have a unique, well, not a unique ability. They have a different ability. There's other types that have this ability. This ability is called mutability, which is the ability to have mutations performed on them, which means we can initialize a list and we can change it. We can change its size. We can change the elements inside of it. So basically, we'll start off talking about lists, and then I'll show you why they relate to loops and why I want to teach them together. So basically, a list is a data type that is a collection of other values from other data types or other lists potentially. You can have a list of lists. So let's look at how we would make a list. So you remember with strings, we make a string by surrounding it in quotation marks. You can use single or double tick quotes. With a list, you surround the list, or you delimit the list with square brackets, what we call square brackets. And these are just the I mean, you can see why we call them square brackets, because they're brackets that are kind of square-like. So I'm going to call this list. You notice that I left out the I. That's intentional. Remember at the beginning when I was talking about, or a few classes ago, I guess, I was talking about you can call your variables or your parameters whatever you want, except you want to avoid certain keywords. There's certain keywords that Python will like not let you use. It'll give you an error if you try to use those as variable names. And then there are certain other values. There's certain other, well, any built-in function. Python will let you actually override that function name and save a variable to the same name, in which case you lose access to that function. So there is a function in Python called list, called list, and it relates to lists. So we don't want to call a variable list with an I, or list with, I don't know, you can spell it however you want, but the sort of the canonical way to spell list as a variable is LST. So often you'll see LST. You'll see me do that. So LST for list, and here we have an empty list. Let's just print LST. Okay, cool. So I can add things. Let's put some values into the list. So 467,225. 467,225. Okay. So this is just, I just made a list of numbers. If you're familiar with another language that has arrays, lists are similar to arrays. If you're familiar with JavaScript, JavaScript arrays and Python lists are essentially the same thing. You have different names for some of the methods, but they are very much the same, obey a lot of the same kind of constraints and rules. You might be familiar with another data type that that is similar from another language that forces you to only use one type of value internally at a time, so you'd always have like an array of integers or an array of floats. So those are called homogeneous lists. Python lists are heterogeneous, or excuse me, yeah, heterogeneous, meaning we can mix and match data types, so they're untyped lists. So if I wanted to say hello and let's say 43.7, so I have a mix of data types. I've got integers, I've got a float, I've got a string. Let's do another string. Yeah. So you can see, same deal, right? So I can mix and match data types, although it is typical that you will have a list of one type at a time. It's usually the case that you'll have like a list of strings or a list of integers or a list of lists of integers, or something like that. So we'll just stick with a list of integers. So one thing that I want you to take note of is the order that I typed these in, that I put these into the list, was preserved when I printed this out, right? So the order matters. The order is preserved with lists. There are other data types where that's not the case, where the order of that, whatever that other collection, like sets and dictionaries, this is true of, we don't think of those as having an order in the same way that we think of lists as having an order. Cool. So it's common when we have elements in a list, it is common to want to be able to retrieve those elements, right? So lists have an implicit feature called an index. And when I say implicit, it means it's just implied that it's there. We don't have to like do anything to make it be there. Every element in here has an index number assigned to it. And we can tell what that is based on its position, because the first index is 0. The very first element in a list is located at index 0. So the way, if I wanted to access the element at index 0, what I do is I would print the list, and then I put square brackets after the list. This is called subscription, or sort of incorrectly, it's called indexing. Sometimes you'll hear me call it indexing or subscription, or subscripting, or subscription. So the more correct term is subscripting, although often, like I said, often I will say indexing. So we can index into list or subscript into list at index 0. So the way we would read this is list sub 0. And if you're familiar with, if you have a strong math background, if you're familiar with a subscript in math where you'll see some array, let's say array A contains, or it's a vector of integers, and you want to get the first integer, you say a sub 1, and you'll do the little subscript below the a or whatever. So this is meant to, obviously it doesn't look like that, but it's meant to model that, and that's why we call it, that's why we would say list sub 0, right? So list sub 0 is going to be the first element in that list. So that's going to be that 4. Let's do a few more. List sub 1, list sub 2, list sub 3, etc. Right, so if I wanted this this 2 here, I guess that would just be 4, right? 0, 1, 2, 3, 4. So that's index 4. And let's just be clear, I'll make this a 24 so we know that that is indeed the one I'm getting. Somebody's asking a question related to JavaScript. So JavaScript arrays are Python lists. Yeah, basically, I can't think of a meaningful difference between the two. There probably is, but on a high level, yeah, if you're familiar with if you're familiar with JavaScript and you know what an array is, you know what a list is in Python. Then there's a follow-up question: JavaScript objects are what in Python? JavaScript, the way JavaScript treats objects is really weird. It's the only language that JavaScript is the only language that I know of that has a literal object, has an object literal. Python does not have an object literal. There's a data type that is in Python that's surrounded by curly brackets that has key value pairs called a dictionary, and it's not like an object really at all. It's a pretty different thing. The most direct analogy, Python has objects, but Python calls them classes, and they do not have a literal form like they do in JavaScript. So the thing that is an object in Python doesn't look like objects in JavaScript, and the thing that looks like objects in Python doesn't behave like objects in JavaScript. So it's a little weird. That was something that was really confusing to me when I first learned Python, because I was looking at dictionaries and thinking, oh, these are like objects, and they're not really. So there's some pretty significant differences there. So that's a rabbit hole. We just viewed into the top of it, but I don't want to dive into it. Cool. You got 2 for list sub 4. Yeah, I kind of changed it out from under you. I'm using this list. Oops. I changed that second 2 to 24 since I had a repeated number in there. So just so we'd be sure that we're getting this 2 instead of that 2. So cool. All right. How are people feeling about this so far? I want to do like a temperature check. Just give me how are you feeling about lists and accessing an element with an index? 1, 2, or 3? 1 is an acceptable answer. Okay. I'll get all 3s, I think, so far. Okay, I see it too. That's okay, good. Thanks for being honest. Okay. Thank you. One starting at 0 is odd. Okay, cool. So I know this is a little bit of a, there's kind of I feel like I just kind of went over a lot. And I want to move on because we've got a lot more to get to. Seems like people are generally all right with this. If you're struggling, feel free to ask questions after class or DM me, and we can meet and go over stuff. I'm happy to do that. If you wanna meet during the day, during the week, I'm available for that. Just let me know. Okay. So let's look at something else about lists. So I'm going to create an empty list. I'm going to print off the empty list. Big deal, it's an empty list, there's nothing in it. So remember how I said we can add things into lists. So lists have, this is a method. The other data types that we've looked at have other methods that do other things. What a method is it's like a function that lives in the domain of a certain data type. It is a property, it's a function that is a property of a given data type, right? So lists are a data type, they have a property, they have properties that are like functions. When a function is a property of a data type, we call that a method, not a function. But it's very much like a function, right? It performs some process, it has a definition somewhere. We're not going to get into defining methods in this class. I have a like intro to object-oriented programming lecture, which I will probably give for a study hall maybe next week or so, depending on interest. I might try to gauge people's interest in that later. But append, what append does is it alters the list. It causes a change in this list. So if I append to this list, in the parentheses, it will append whatever I tell it to append. So let's say I create an empty list, I print off the list, we're going to see an empty list, then I append the value 4, and then print off the list, we'll see the value 4 in the list. Of course, if I append more things, we'll see more things. Of course, it doesn't have to be just the value 4. We can append strings, whatever we want to do. Okay, so append is something that you're going to use like all the time. You're going to be appending to lists a lot. This is worth remembering. I know we cover a lot of things. I don't want to say anything is like necessarily worth forgetting, but like, I want to emphasize this because you're going to be using lists and appending to lists constantly. Okay, let's pivot slightly and look at for loops real quick. So we're about to get into iteration. This is exciting. I'm excited by this. Okay, so for loops. So let's say I have I'm going to call this a source list, SRC LST. Now I could spell this out, but I don't know. I'd have this 3-letter variable pattern thing going, and I'm sticking to it. So source list. Let's say 5, 6, 2, 7, 9, 15, 27, -3, 3. Okay, so I've got some numbers here, and let's say I want to go through this list, and I want to create another list of squared numbers. We'll just call it squares. So I want to go through and I want to look at each element in this list individually and say, okay, so this element is 5, 5 squared is 25, 6 squared is 36, 2 squared is 4, etc. Okay, so I'm going to start with squares with an empty list, and I'm going to model that process exactly as I had it written. Sorry, we've got a couple questions here. So somebody's asking, we've got a number of questions. I'm sorry. Hope I didn't leave anybody hanging too bad. Okay. Somebody's asking, so lists are mutable, but strings are not, correct? Yes, that is correct. Strings are immutable. We'll dive into mutability and immutability as like its own concept. Probably not this lesson, but next. Next lesson is going to be, I can already tell the next lecture is going to be all about lists and loops, and mutability will be in there. So, okay. When appending to the end, when appending, we are adding to the end of a list's position, yes? Okay, yes, so that's correct. There are two ends though, so to be clear, you are adding to the right-hand side. You're adding numbers from left to right. So if I appended to this, if I appended 77, it would go here, always there. There are ways of, you can use insert to put an element anywhere in the list, including at the beginning. There are methods for doing all kinds of manipulation to lists, and we will get into those. But append is by far the most common, and it's the one you use kind of all the time. Okay, cool. So back to this example, we've got this source list, which is a list of numbers. We've got an empty list of squared numbers. And what I'm going to do is I'm going to create a process that goes and looks at each of these numbers one at a time, squares it, and then appends it to the squares list. So to do that, and I want you to kind of bake this in now. You're going to be solving problems. You're going to be looking at collections of information in lists, in dictionaries, in tuples and strings, in NumPy arrays, in pandas, data frames, in various other forms. And you're going to think, I need to insert some process. I need to do some process for every element in this collection. Or I need to look at each one of these and do such and such, right? So if you describe the problem, when I'm working through something, I don't know how you all work, but I will vocalize or sub-vocalize the problem in my head and kind of talk it out, and I have these what I call it, like keywords that when I think a certain phrase or a certain word, I think, oh, I know that way of thinking about something corresponds to this in code, right? So when you think of through a problem and it kind of matches that description, I have a collection of things, and I need to do something to I need to do some process to every one of these, or I need to look at each one of these and do some process. You can essentially deduce that you've just described a for loop, right? So we can write a for loop to model that behavior. So I'm just going to write this list. I'm going to say for num in src lst. And every time you write a for loop, let's look at the anatomy of this. We've got the for keyword, for, and then an identifier. We could call this foo or shmoo or poodle or whatever, but since this is a list of numbers, I'm going to call it num, right? So this word here doesn't matter. It's just an identifier, like a parameter or a variable name. You call it whatever you want. And then in means you're saying this identifier applies to one value at a time in order from this source of things, right? In this case, this is a list, right? So the anatomy is the for keyword, an identifier, the in keyword, in, and then some iterable object. And what does iterable mean? Well, it just means something you can iterate through, something that you can iterate through, and you will learn what things are iterable. Um, Generally, if something looks like a group or a collection or a sequence of things, you could probably iterate through it in Python. Or you can at least try. Worst thing that's going to happen is you'll get an error. So a list is a group of stuff, so we can iterate through it. So every time you write a for loop head, now notice this takes a colon at the end, right? This is familiar from control flow, if, elif, and else, which ends in a colon, and functions, which have a head that ends in a colon. In all of those cases, the line that ends in a colon, I call that line the head, the function head, the condition head, in this case the loop head, and then I call the indented code on the next line, I call that the body. So that's pretty common to call that the head and the body. So this is the loop head. The loop head has that anatomy of the for keyword, the identifier, the in keyword, and then some iterable object, such as a list. So every time you write a loop head, print, before you get into the problem solving, it can be tempting to be like, yeah, I know what that is, but this is just the thing. You want to make sure that you do know what your identifier is, because sometimes you'll iterate through something and you'll assume that you know what your identifier is, and it won't be what your assumption was. So in order to curb that, ultimately you want to develop the habit of just printing off out of principle, whether you think you know or not, just print off out of principle the uh, the element or the identifier that you just created, right? So if I do that and I run the code, I'll just give it a quick check. 56279, 56279, right? So I can see I'm printing off each number individually from my list, right? And to prove that, let's add 10 to it. Or let's add, we'll add 10 to it, right? So 5 plus 10 is 15, 16, 12, 17, 19, 25, 37, 7, 13, etc., right? So that proves that I'm able to, under this name num, I'm able to access each of these numbers individually. Okay, cool. So now that I've established that I've acquired the correct, that my identifier is what I think it is what I need it to be. Why don't I prove this, since I'm gonna append the squared number, why don't I square the number, make sure that I can do that. Looks like I can do that, that's fine. And then from here, I can just append it into squares list. So squares dot append num squared, and let's just run that. Of course, nothing happens because I'm not printing anything. So, but I didn't get any errors, Quares. We'll print squares, and now you can see I have a list of the numbers from source list that are squared. So we could wrap this up in a function. Let's call it def squares list. We'll take in a source list, and I'm going to call this list like that. I'm going to return list run or return. Okay, cool. We'll call that sum list. We'll print squares list with sum list as an input. Cool. Now we have a function that takes in a list as an argument, and it returns a list. It takes in a list of numbers as an argument, and it returns a list of all the numbers in the input squared. Cool. Looks like we've got another couple questions. Somebody's saying also when you iterate through num, I thought it indexes at 0. Is there a way to access the individual numbers or the other indices in the list through the for loop and list? Okay, so there's a lot going on in that question. I think what you're saying is, okay, I think this question is in regards to when we write a for loop and we iterate through a list, how do I iterate through it in a way where this identifier is where the identifier represents the index. So the way I have this written, the identifier will represent the element. Element is what we call the things in the list, right? Now I could call these numbers, but I mean, we could have a list of anything, right? This function will only work with a list of numeric values, ints or floats, but the objects in the list we call elements, and their location we call indices. Yeah, okay, so that does sound like what you're asking. So the question is, how do we, and I know I think you know this, I'm sort of just doing this for clarity with the recording to make it clear what I'm talking about here and just make it very clear. So the question on the table is, how do we iterate through the elements of a list and or the indices of a list and have either one or both of those represented with the identifier, right? So in this case, num represents the elements. So let's look at how we would iterate through the indices. This is a really great question, and it fits perfectly with what I want to get into next. So before I get into this, it is common to want to do either one or both. If you have to choose one, though, the index is kind of more powerful because you can always recover the element from the index. But if all you have access to is the element, you can't necessarily infer the index unless you did. I could kind of infer the index. Well, this would work for inferring the index. I could start a counter variable I'm actually going to start it at -1 and then say idx plus gets 1, and then the first time through this loop, idx will equal 0 after this line if I just leave it alone and make sure it's always at the top. So I could access, I could model the indices that way. I'm not really, you don't really access the indices from the list the same way you do the elements. You know, this is directly asking for the element from the list. And I'll show you the way, you know, this is one way. If I had this IDX, this index variable, this would work for like creating something that would follow the indices accurately, but it's also a weird way to do it. So we'll look at the correct way to do that. So let's just rebuild this problem, but let's just do it. Yeah, actually, let's rebuild it in the next step. And I'll show this more in isolation. So when you want to access the indices of a list and you want to iterate through just the indices, which is not uncommon to do, it's valid to do either one. There are scenarios where you want to do one, scenarios where you want to do the other. So we looked at iterating through elements with a for loop. Let's look at iterating through indices. In order to do this, there's actually two functions that we need to learn, and I'm going to show them one at a time. So one is range. Most of this time that you see range is in an iterable, in a for loop. Sometimes you see it in other applications, but almost always it's as the iterable of a for loop. So I'm just going to show it initially like that. We'll say for I in range, and I'm just going to do range 10. So the reason I'm calling this I is there's a standing convention around when you're iterating through some sequence of some series of sequential numbers or just a number in general. Calling it I is just kind of a standing convention around doing that. The way I had it explained to me is that because I is short for iterable or integer or increment or whatever. So I is the thing. So you'll often see me use I, and that just generally alludes to a number, probably a sequential, in a sequential order. So I'll just print I. Okay, so notice range 10, when I iterate through range 10, I get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So this kind of is similar to list indices, right? Because it starts at 0, and if I have a list with 10 elements in it, the indices are 0 through 9, right? So if I had, let's do this, if I had some list and I could tell if I had a function that would return, that if I passed this list to that function, it would return an integer representing how many elements were in this list, I could plug it into range. Well, good news, such a function exists, and that function is called len for length, okay? So if I print, let's do print sum list, sum, okay, sum list, and let's print the len of it as well. Okay, well, it's a little hard to see. So there's 9 elements. So if I iterate through range len sum list, notice I get indices, right? And of course, if I want the elements, I can say elements equals sum list sub I. This is also a really common thing to be able to do, to want to be able to do. So now I have access to the element as well as the index. So when you want to iterate through indices, you can use, one way to do it is to use range len of your list. So you need to pass your list to len, and you need to pass that len call to range. Okay. I'm just catching up on questions here. So somebody's saying, so range indicates the range of elements and not the index. What you do is you don't like extract the indices from the list like you do the elements. When you iterate through the elements of a list, you kind of extract the elements directly from the list. And that's not how you get the indices. What you do is you model the indices using range. You make a range that goes from 0 up to 1 minus the length of the list. Okay, cool. No, I appreciate the questions. That's great. I'm glad you're asking. You're probably not the only person with those questions. So, okay, great. So hopefully that's clear. So let's rewrite this squares list function. Let's rewrite it using range len. So, oops. I want to call this I, and what I want to do here is src lst sub I, and that'll be the same thing. Be an alternate way of doing that. Okay. We are pretty tight on time. I think this is actually a good place to wrap up because I don't want to get into describing another concept in 5 minutes and not really cover it meaningfully. So I think we'll wrap up here just a little early today, and we will pick up with slicing and more information on the range function tomorrow. Cool. So let me stop the recordings and we'll open up for questions.